Hello everyone. My name is Maulik Pandya, student of civil engineering. In this video, I'm going to present what is glass concrete, how it was formed, advantages and disadvantages of it. So without wasting any more time, let's get started. Glass aggregate can replace part or all of the sand and gravel in concrete, for effects that range from colorful terrazzo, to granite or marble-like finishes, to concrete that reflects light like a mirror. Glass aggregate can even be used to produce concrete that literally glows. One of the prettiest countertops I ever saw had clear glass aggregate in white concrete, says Volmer, of Alternative Finishes in Texas. There were lights underneath it that shone through and made the whole thing glow faintly. It was just unbelievable. Glass aggregate can also win a project the green stamp of approval, since it almost always comes from recycled glass, saving landfill space and requiring no mining. Glass aggregate is typically graded by color and size. Sizes can range from 6-inch rocks to gravel-sized pieces to a fine talc-like powder. Polishing, grinding or other exposed aggregate techniques are employed to reveal the glass. Or glass can be seeded on the surface and then exposed. Colored glass can be coordinated with the matrix of integrally colored concrete. In general, lighter colors of glass are used in darker matrices, and vice versa. But not always. A dark brown glass in a dark brown matrix can have an appeal all its own. Mixing light and dark colors of glass will give you a terrazzo effect. If you use clear glass aggregate, it will take on the color of the matrix, and it will add the most depth. Since glass is acid resistant, acid staining will color the surrounding matrix without affecting the color of the aggregate. Finely ground glass can add background colors to the matrix. Using finely ground clear glass in place of sand can make for purer colors of concrete. Finely ground glass also lends itself to highly polished finishes. A marble or granite look can be attained by putting a high polish on concrete made with finely ground, earth-toned glass aggregates. As for strength, glass aggregate can match, exceed or fall short of traditional aggregates, depending on size. Studies have found that very finely ground glass aggregate used in place of sand actually increases the strength of the concrete, whereas gravel-sized glass aggregate decreases strength. Mixing fine and coarse glass aggregates can have a net effect of 0, rendering concrete no stronger or weaker than that mixed with traditional sand and gravel. Glass aggregate can be obtained from a variety of sources. Locally, recycling centers may have cullet, crushed bottles and other glass, cleaned and sorted by size and color. Nationally, specialty glass manufacturers melt down bottles and window glass to produce glass aggregate for terrazzo floor contractors, landscapers and decorative concrete artisans. With a small investment in a high-impact glass crushing machine, you can make your own cullet. Alkali-silica reaction must be considered when using glass aggregate outdoors, or anywhere else that the concrete will be exposed to moisture. Beware of the dreaded alkali-silica reaction, an unhappy phenomenon in which the silica in glass and the alkali in cement create a gel that swells in the presence of moisture. The reaction may happen right away or it may take 20 years, but in either case it can cause cracking. Any source of moisture can set it off, including mopping, using excess water in the concrete mix, and so forth. But the alkali-silica reaction can be prevented. Engineers at Columbia University, committed to developing more environmentally friendly building materials, discovered that the reaction can be avoided if the glass is ground finely enough to pass through 50 mesh or smaller screen. They also found that the mineral admixture metacolin will suppress the reaction, an effective but expensive solution. Now came advantages and disadvantages of wasted glass concrete. Among all the waste materials that have been recycled, batteries and steel are the most recyclable. Although glass is a material that can be recycled, just 34% of waste glass has been recycled. The main reason why collected mixed color waste glass isn't recycled is due to its chemical composition. Typically, glass containers consist of sand, soda ash, limestone and cullet. Sand is glass's main component and is its source of silica. Soda ash is added to the mixture to decrease the melting temperature. The chemical compositions of different glass colors are slightly different, which affect their melting temperature. Therefore, glass containers can't be properly recycled unless they're sorted based on their color. Using glass as a postcellin. Postcellins are cementitious materials added to a concrete mixture to enhance its mechanical and durability properties. When grinded to a powder, glass is one of the natural postcellins that improves concrete's fresh and hardened properties. While concrete is in its plastic phase, glass powder will increase its workability, so less energy, cost and time are required to place and consolidate the concrete. While the concrete is in its hardened phase, concrete containing glass powder exhibits better strength, freeze-thaw resistance and sulfate resistance. Glass powder can be used to replace Portland cement, typically at a 10% to 30% replacement level by weight. Glass aggregates and ASR. Besides powder, waste glass can also be used as an aggregate in concrete in the form of fine or coarse aggregates. Since aggregates occupy approximately 70% of the concrete, using glass colored as aggregate in concrete not only results in incorporating more waste glass in concrete, but it also decreases the energy and time required to ground the glass particles into powder. Eliminating ASR reaction. There are several ways to eliminate the likelihood of deleterious ASR reaction in concrete containing waste glass aggregates. Using low alkali Portland cement and/or incorporating supplementary cementitious materials, SCMs, such as silica fume, fly ash, slag and metacoulin can mitigate ASR distress in concrete containing waste glass aggregate. Among the conventional SCMs, silica fume and metacoulin are the most effective ones. Previous studies showed that using approximately 10% of either silica fume or metacoulin can mitigate the ASR distress in concrete containing 100% glass aggregates by almost 90%. Okay, that's it for today. Please let me know how was the video by comment down below. If you found this video is informative, please hit that like button. And for more videos like this, smash that red subscribe button. See you all in the next video. Till then, bye bye.